Hi, my name is Alexander Knopp and this is Introduction to Mathematical Logic. If you have not seen the Introduction to Mathematical Reading, I recommend you to have a look. Mathematical logic is a branch of mathematics that's studying mathematics itself. In other words, it's studying proofs. In this short class, we are going to study the basics of this vast field. In order to study something mathematically, we need to give a formal definition. In the first part, we are going to study a simple model which is called propositional logic. In the second part, we are going to study a bit more involved model which is called the predicate logic. In this video, we are going to define what it means a statement in a propositional logic. In other words, we are going to define propositional formulas. So phi is a propositional formula on the variables x1 to xn if either phi is xi for some I from 1 to n, or it's a negation of another formula or phi is a conjunction or disjunction or implication of two other formulas, psi1 and psi2, and both of them should be propositional formulas on x1 to xn. If we have a formula, it should be a way to compute the value of this formula. So let phi be a formula on x1 to xn and v1 to vn be some true or false values for x1 and xn. So we are going to consider three cases like this, and in each case we are going to define the value of phi. So if phi is equal to xi, then the value of phi is equal to vi. If phi is equal to negation of psi, then the value of phi is equal to the negation of the value of psi. Finally, if phi is psi1 sharp psi2, then the value of phi is equal to sharp of the values of psi1 and psi2. Let's consider an example. Imagine that we have a formula phi equal to x1 or x2 and x3, and we wish to find the value of it with v1 equal to true, v2 equal to false, and v3 equal to true again. Note that the value of x1 under this substitution is true, the value of x2 is false, and the value of x3 is true again. Hence, the value of x1 or x2 is true or false, which is true. And finally, the value of phi is true and true, which is true again. Let's prove some simple theorem about the formulas. For example, we can prove that the formulas are kind of associative. In other words, if you have three formulas, A, B, and C, on the same variables, then A or B or C is the same as A or B or C. for any values of v1 to vn. And the same can be proven for AND. How can we prove this? So let A be the value of A, B be the value of B, and C be the value of C. In this case, the value of A or B or C is equal to A or B or C. But at the same time, it's equal to A or B or C, which is the value of A or B or C. And it proves the first statement. Similarly, you can replace everywhere disjunction by conjunctions and prove the second statement. Since we have some kind of associativity, we can define disjunction and conjunction of more than one formula. So let phi1 to phi n be formulas on x1 to xn, then conjunction of phi i's from I from 1 to n is phi1 and phi2 and da 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 da. And disjunction of phi i's I from 1 to n is phi1 or phi2 or phi3 or da da da. Using this notation, we can show that any function can be represented as a propositional formula. In other words, the value of a function is equal to the value of a formula for all values v1 to vn. In order to prove this, let's give the following definition. xi to s is equal to xi if s is true and not xi if s is false. In this case, you may notice that if you have a conjunction from 1 to n of xi to si, then it's equal to true if and only if s1 is equal to v1, da da da, sn is equal to vn. Okay. So now we know how to satisfy one substitution and exactly one. Now let's write s1 1 da 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 s1 n da 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 sk1 da 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 skn be all s1 to sn such that f of s1 to sn is true. In other words, it's all the assignment to the function f such that it's satisfied, it's true. Then f of v1 to vn is always equal to disjunction from j from 1 to k of conjunctions from 1 to n of xi to sji. Indeed, if you substitute one of these values, this is satisfied because the corresponding conjunction is satisfied. If you substitute something else, none of them is satisfied, and both of them are false. This formula is called a disjunctive normal form of a function f. And it shows that this theorem is true. In this video, we discussed how to formalize the notion of a statement in the propositional logic. In the next two videos, we are going to discuss how to prove them in the propositional logic. If you have any questions, ask them in the comments. See you later.